Welcome back, everyone. Today we are going to talk about how to code a linked list. So how do you code a linked list? So to code a linked list, we can start off with let's create a new file, save it. Then we're going to call let me call it linked. Let me call it linked. I'm spelling linked properly. Let me call it linked.py. So after creating my linked list, so to create a linked list, we need the following. We need a node. And now, in fact, before even we go to what a node is, what is a linked list? So let me try to explain what a linked list is. Let me open Paint. I think Paint will be the best to explain what a linked list is. So we're explaining what a linked list. So a linked list is simply a data structure whereby you can have one node, then you have another node, you have another node in a sequence, and another node. Now these nodes can contain different information in them. So this one could have numbers, this could have a string, this one can have a boolean. They could have different data types. Now the thing in a linked list is that this list points to this one points to this one, and this one points to that one. Now these elements here, this one here is what we call a node. This is also called a node. This is also a node. And this is also a node. So a node, what a node has, it has some data, then it also has a pointer, and this is the pointer. This one here, it's the pointer. So that's what a linked list is. It points to the next node or to the next element in that linked list. You could also have a doubly linked list whereby this node points to this node, and then this node points back to this node, and the same, this one points to this node, and this one points back to this node. This one points to this node, and this one points back to this node, and that would be a doubly linked list. So from my explanation, how do we start off by coding? So we need a node. So to create a node, you can call our class node. I call my class node. Since now I've created a node, and remember we said that a node has to have a way to store data and a way to point to the next node. So what we can do, we can initialize our class. So our class, the node will have to take in the data I want to store in that node, and then that data I'm going to store it in self.data will equal to data. Now the node also has to point to the next. It has to point to the next node. So I'll say self.next will equal to none. So in this case, at the beginning it's pointing to no. It's pointing to no. It's pointing to no node. So then what I'm going to do, I'm now going to create my class, the class for the linked list. So I'm going to call class linked list. Now my linked list can have many functions. It can have a function to append. So I'm going to say append. So this append will take in the data, and then it will append it onto the linked list. So let me call pass. So what this append function does, let me open here Paint. It comes to my last node after me creating my node. Here it will come to the last node, append it, and make this last node point to it. So this last node will point to it. So if it has a doubly linked list, it will also point back to the last node. So then I will have another function called prepend. Let me call it prepend. Self, then it will take in the data I want to prepend. Then I would have to carry out the operation. But what is prepend? So prepend is here. When you have my head node, so this is my head node. The first node in a linked list is my head node. So this is my head node. To prepend is to put a node before the head node, meaning that this node which you have prepended will become the head node. So this node should be point to this node. And remember, the head node does not point to any other previous node. It is the head, it's the first node. So that would be prepending. Then I'm going to create another function, which will be, I'm going to call it delete with value. So if I wanted to delete a node from my linked list, I'll just pass in the value of that node, and then I'll be able to delete it. So let's say delete with value. So what you do, what it will take in, self, then data, then pass. I'm going to carry out the operation. So this is the basic way how a linked list looks like. But now we need to code the linked list. Now in a linked list, one, we need to keep track of the head node. That's the first node. So to keep track of the head node, we need a head variable that keeps track of the head node. So to do so, we shall first initialize our function. When we initialize our function, let's initialize our function. And our initial function, when we initialize it, we are going to create the variable self.head, which will keep track of the head node. But initially, it will have none because there is no head node that we have yet defined. So then now we're going to come to append, adding a node in the list. So now to add the node, what we do, we are going to say, what if the head node is none? That's the first thing. What if the head node is none? So if the head node is none, what we do, we can say if self.head is equal to none, meaning that if there is no head node, meaning that the first data that someone sends into the linked list will be our head node. So we shall say self.head will equal to node, then we shall pass in data. So meaning that the first data that someone sends will be our head node. So after this, we shall just return, meaning that we return the function. The function ends there. Okay. Now what if there was already a head node and a bunch of information? So let's come back here. So let me select the whole of this and first delete it. So what if we had this scenario? We had a node, another node, another node, another node, and then they are all linked to each other. This is linked to this one. The head node is linked to the next node, then the next node is linked to the next node, and then the next node is linked to the next node. And we wanted to append a new node at the end. So what do we know? Initially, the linked list has only access to the head node. We have access, if I delete this, let me put in the arrow here. We have only access to this head node. That's the only node we have access to. Meaning that we need to get access to this node. But how do we get access to this last node? This last node has no pointer, meaning that its self.next is none. So what we shall do, we shall write a while loop, which will be given the head node, right? It will be given the head node. Then the first loop, it will check self.next. Then this self.next will be this node. So it will check if this node's next is not equal to none. If this node is not equal to none, then we shall set our current equal to this node. Then we shall continue the loop until we reach our node where its self.next is equal to none, and then we store that node in a variable which we might have defined. So if it's not making sense, let me code it and you see. So now what we shall do, we shall say our current. So this current is going to keep track of our node as we loop through. So our current will equal to self.head, right? Then we shall say while current dot next is not equal to none, while current dot next is not equal to none, we continue looping through. So now let's come back here and see, well, what does current dot next not equal to none mean? Meaning that if I pass in my self.head node, then it checks its self.next. It checks the next of the head node. And then if the next of the head node is not equal to none, which it's not, it will continue the loop. Then we shall set our current equal to self.head.next. Then it will check again if this one's next is not equal to none. If it's not equal to none, it will continue the loop. It will check again if this one's next is not equal to none until it reaches a node where its next is not equal to none. And it reaches that node where its next is not equal to none, it is going to stop the loop. So it will come here and it will check, current.next is equal to none. So it's equal to none, it will stop the loop. And then when it stops the loop, this node here that we have now gotten, it would be in the current variable. And then we shall set its next equal to the node we want to append onto the linked list. So, in simple terms, let's go through the code again. Let's see. This is the one. So, our current.next is not equal to none. So what we shall do, we shall say, as long as our current.next is not equal to none, we shall say let current.next, let our current equal to current.next. Then after we loop until we reach the node where its current.next is equal to none, what we shall do, we shall just say let the current, that's the node where its current.next is equal to none, let its .next equal to our data that we have been told to append. So that's how you append onto a linked list. What if we wanted to prepend? Again, prepending is putting a new node to be the head, meaning that our current head, the new node should point to the current head. So the new node which we are trying to prepend should be the head. So to do so, what we shall say let our new head, let our new head equal to node. So our new head is equal to node when we pass in the data. So we have created our new head node. Then we shall say let our new head node point to, let its next equal to self.head. So if its next is equal to self.head. Now, but in our linked list here, this self.head is still the old head. So we need to set it into the new head. So we shall say self.head equal to new head. So we are done prepending. Now, what if we wanted to delete with value, meaning that we pass in some data and then we delete the node with that data? So what we shall first check. What if our linked list is empty? So just say if self.head, meaning that if there is no head, is equal to none, meaning that there is no head, what we shall do, we shall just return, stop the function and return it. What if the data we want to delete is the data in the head node? We shall just say if self.head.data is equal to the data we are trying to delete. What we shall do, we shall say now, when you're deleting information in a linked list, what you do, if you wanted to delete this information, I just get it and then I get this node. Let's say this node. If I wanted to delete this node, what I would do, I'll just get this node, I remove it out of the equation. Then after that, I point its previous node to the next node, meaning that I've deleted it. So in this case, if I wanted to delete the head node, what we shall do, we shall say let self.head, meaning that the head, this head node here in the linked list, let that head node equal to head.next. It means that in the linked list we have now forgotten about the head node, meaning that remember in a linked list the only node you have access to is the head node. Then from there you can move where the head node points to another node and the next node points to the next node. So if we change our head node and then we make our new head node to be the next node of the head node, then we have deleted the head node. So now we return the function. What if it was not the head node we wanted to delete? So what we shall say current. So I previously explained how to loop through the nodes. So I was just say let current equal to self.head. So after our current equal to self dot head, let me change this to self dot head. So after our current equal to self dot head, what we shall do, we shall loop through the nodes. So we shall say while current dot next is not equal to none. We shall say if the current dot next is not equal to none, we shall be looping through all the nodes. What we shall do, we shall say if current dot next dot data is equal to data. Now, why did we say current dot next? Because remember, our current initially in the beginning of the first loop, our current is the head node. But remember here we already accounted for data if there is data in the head node, meaning that the node we need to check is not the head node because we already accounted for it. It's the node that the head node points to, that is the current dot next or the head dot next, which is the same since we say let current equal to self dot head. So we check its data if it's equal to data. If our current dot next is equal to data, what we shall do, we shall say let the current dot next, meaning that the current node we have checked, the current node whose data is equal to the data we want to delete, let its port equal to current dot next dot next. Let it equal to the node that it points to. That's what current dot next means. Then that is it. Then the node will be the node will be what? Deleted. But to make sure that the loop continues, we have to select current equal to current dot next. I think also the same should be done up here. Yeah, for the loop to not be infinite, we shall have to select. We already did let current equal to current dot next. Yeah, so that's how you would implement a linked list. Thank you for watching. If you enjoyed the video, hit the like button. Thank you so much for watching.